This is Module 14, where we will cover the unit pound, which is used for prime coat, tack coat, steel, and fertilizer. Page B2 of the dot guide covers the various pay items for pound and the accuracy of measurement, which is to the nearest pound. Required documentation can vary depending on the item. If it's rebar, you can do calculations per the spec book on unit weight per length, or on some standards there are details in the plan on how many pounds of rebar are contained within that standard. So you could say built according to standard, or you could have weight tickets for rebar. Structural steel could also have weight tickets. You can actually calculate the pounds of steel given the shape, type, and thickness of the material. For fertilizer, you need to do a little calculation to convert the amount of material supplied by the nutrient content. So you need to show those calculations and use Form BC81 if it's available and can be applied to the item. For prime tack coat, it's paid by the pound, which must be a weight item. In some cases, it could be paid under ton, but typically the more modern specs are converted to pounds of residual asphalt. Let's cover documentation for the various bituminous materials. We have a prime coat and a tack coat. You could also have a polymerized bituminous material as a prime or tack coat. The first special provision developed was from the Bureau of Design and Environment as a BDE special. That was incorporated into the April 1st, 2016 spec book, and I doubt if there's any older jobs that utilize the BDE special provision at this point. So in the 2016 book, Articles 406, 13, and 14 apply. If you want some more information, the construction manual also has some information under 406, 14, the basis of payment for tack coat. Also, appendixes page 117 to 120 has good information. Those are all good to tab for conducting work on bituminous materials, prime and tack coats. You might ask why all the changes to prime and tack coats over the last few years. It's always been viewed as a minor, non-critical item, and that's been the main problem with getting quality applications out there in the field. So we had a lot of streaking, a lot of abuse of prime and tacks. Contractors for a while were allowed to add water and dilute the emulsion, and this was abused quite a bit because the way the water was added, it would break in the distributor truck itself, and we would be applying essentially brown water out in the field that had little asphalt in it. And the hard asphalt was being left in the distributor truck that had to be cleaned out at the end of the year by the contractor. So we were paying for something and we weren't really getting it on the road. Quite a bit of research was done, and it showed the need for higher application rates and much better coverage to help prevent a number of the performance problems we've been seeing. You may have seen debonding, especially on interstate systems in the wintertime. This was all tied back to poor tack and prime coats. So one of the things that came out of this is that terminal blending of water needed to be done rather than at the contractor's site. This produces a more stable material. The pay item was switched to residual pounds of asphalt to help produce a better result and a better check in the field. And then a method was developed to check the residual rate applied. Here's some photos of some of the problems that we've seen in the past. Here's a distributor truck that's essentially going too fast for what the spray nozzle setup is, and it's just being a splatter on the roadway. It's not a good uniform coverage. In their case of streaking, where we got actually blank spots in between the individual nozzles. And then here's another setup where we got kind of heavy nozzle application in streaks. And then when we do get a uniform coverage, it wasn't being allowed to cure properly and being picked up by traffic, not only the trucks delivering asphalt material, but the material transfer device, and picking up and cleaning right in the wheel pass where you need the adhesion to the new overlay the most. So we had good tack coat every place else, but right where you need it in the wheel path. So these are some of the problems trying to be addressed by the update and specifications. Getting a good application starts with a good distributor truck. This obviously does not meet specs. And this is not even a distributor truck. This is something else related to the farm. Let's talk about the nozzles on our equipment. This is a very critical element to make sure we get a good tack coat applied. We are applying at a very low rate of about 0.12 gallons per square yard. And that's even a diluted emulsion. So if it was not diluted, it'd be even a lower rate. But with 0.12 gallons per square yard with a dilution, you can get a reasonable coat. However, you need to use the proper nozzle. You notice that a number of these nozzles are in the range for doing seal coat work. So to do a prime job or tack coat, you need to go to a specialty nozzle that's specifically designed to do tack coats. And the reason is it gives you a better fan out of the material. Otherwise, you're going to get streaks like this. Here's some examples of good uniform coverage where the equipment has been properly prepared. We have the right nozzles in place. We have overlap of the fans. And what I mean by fans is the spray overlaps. Gives us a nice uniform coverage. It's also important that our pavement be very clean to begin with, because even if we apply it properly, allow it to cure properly, if there's a lot of dirt and debris that the tack coat is sitting on top of, is not penetrating through that, and it will pick up on the tires. So here we have the case of the material transfer device going through a tack coat and little to no pickup. So that's what we want. Also developed with this spec was a check of the residual rate. This is done by placing a 1 foot square of fabric or cardboard on the pavement. The distributor goes by, sprays this, and then you pick it up. A number of districts have made so-called pre-weighed kits where this fabric is pre-weighed. And it's been supplied in a kit to where you can apply it to the road, put it back in a bag, or put it in a pizza box, and it will go back to the district lab, get the post application rate on it, weight on it, and a rate determined. So these are available. Talk to your district materials engineers if you have the need to do this. Here's an example of the calculations for doing an application rate verification. And we got a 12 by 12 piece of cardboard. In this case, it's been weighed to the nearest tenth of a gram, placed on the pavement, had a primed truck, and the truck primed on top of it. Picked up the cardboard, brought it into the lab, dried out in the oven till it's weight stable, and then weigh the cardboard plus the prime to the nearest tenth, and then we do our calculations. Here's the prime plus cardboard, the cardboard no prime, the difference being what is applied, and doing a little check to make sure our calculations are correct. So that's all needs to be done. Pretty simple, but it is messy. Talk to your district materials folks on getting the materials to do this exercise. Let's talk about weights in prime application. You can run into a lot of weights as far as tears and loads that come out to the job, especially if you have a prime truck running job to job. You could spend a lot of time driving the scales, getting weights, and in between applications. As a result of that, there's one contractor, and there's maybe more adopting this, but K5 in the Chicago area has adopted the use of what's called onboard truck scales. This is basically where the tank on the distributor truck is sitting on a scale, so you can get the weight of the tank at any given time. It has been certified by the Department of Ag. It does not have a typical scale tag on the truck, but there is a certificate. It takes the place of the certified scale sticker. So treat it as if it's any other scale. Get a copy of the cert letter for your file, just like you would have gotten maybe a photo or at least a scale cert number off of the tag at a fixed scale, and check to make sure it is current and for the correct truck, because there are a couple of these trucks in the company, and they should have the right certification with the correct truck. And even with all that, you still have the right to perform an independent scale check if you have any suspicions that it's not weighing properly. And you can take it and get the scaling done at an independent scale, just like you would tonnage items. So there's an inspection date. They get this updated every year, and just like a regular scale, even though it was done this date, it would not expire until the end of the following year. They have a truck number assigned to it and a decal number assigned to it. So that's the information that you need. Here's an example of the onboard scale ticket that you would receive. Notice it has a truck ID number, some information, date, product that's in the truck. They have the internal customer number. In this case, the RE has placed the contract number on the ticket. Also, the IDR is noted on the ticket. And if it was witness, initial that. So we have the start weight, and then we have the end weight, and the difference is what's been applied to the roadway. So pretty simple calculation here. If the truck is going to be reloaded from a nurse tank, you will have to make sure you zero out and get a final weight, and then start over and get a new weight, and then finish it up with your final weight if you're doing multiple trucks. So let's talk about the documentation for bituminous materials. This goes for both prime and tack coats. They are paid under the current specifications per unit price of pound of residual asphalt applied. Now that's the hard asphalt that will remain after the water from the emulsion has evaporated. So to do this, you must calculate and deduct the weight of all the water, or if it is a cutback, the petroleum products from the weight shown on your tickets, and calculate the residual. The specifications now are written in residual pounds per square yard or square foot, as the case may be. And so we need to know how many pounds of residual material has been applied. And this gets back to the issues we talked about earlier, where the water addition was being abused and we were essentially just getting brown water. So we want to make sure we get the residual asphalt on the roadway. If there's any aggregate being used to cover the prime or tack coat, it is incidental to the work and it is not measured for pavement. So some of the things that you're going to need to do your calculations, of course, are weight tickets. The distributor needs to be weighed before and after placement. So that's the amount of material that's applied over the length and area of the pavement for the prime or tack coat. If you're witnessing, you should initial the weight tickets and collect them at that time. If there's not an inspector available, do not initial the tickets, just make an explanation to the file like we do on other weight tickets. In addition to your weight tickets, you should have some information being provided on the material in the form of a bill of lading. This will indicate the percentage of residual asphalt and any additional water that have been added at the terminal. So this is very important information. It's needed to do the calculations for residual asphalt. You're going to do either a ticket tape and staple that to your weight tickets as far as your calculations, or you could use a spreadsheet. And the calculations are based upon the weight tickets and the bill of lading. If you go to the doc guide pages F71 and F72, there's some examples of this. Let's talk a little bit about physically what's going on in the production of emulsions and the addition of water and how it ends up on the road. First of all, the asphalt producer is going to make a standard emulsion according to specification. This could be an SS1 or a CRS or other type of materials. For prime and tacks, SS slow setting emulsions are typically used. They are roughly a 60-40 blend, 60% being the residual hard asphalt and 40% being the emulsifier and water. An emulsifier is simply soap. There's nothing exciting about it. So we got a soap plus water that is blended to make a uniform emulsion. Another emulsion you may be familiar with is latex paint. It's a water-based paint, and then suspension is the solids. Same concept with emulsions. Now what we're going to do is, since the rate being applied is very low, we want to increase the amount of material so we can slow down the distributor and get a nice uniform coating. So the idea is to have a larger quantity going through the nozzles so it can slow down and you get a uniform coat. That does present some problems in that we're applying more water that needs to evaporate. It could take a little bit longer to break that emulsion to where you can get on it to pave. But that's a basic concept. So we start out with a standard stock emulsion, roughly 60-40 blend. We're going to add water to it. Now it still contains the same amount of residual material in it. We've just literally watered it down. And this is to be done at the producers, not by the contractor. So the producer will supply this, bring it out, and it will be put in a distributor truck and then applied. So when you have a bill of lading coming out to your job that has a original emulsion and water added, this is what it might look like. You have the material being described in its nomenclature. SS1 is a slow setting emulsion, type 1. This is a standard emulsion, producer specification. The bill of lading will show the original percent of residual asphalt in that particular emulsion. And then there will be information on the amount of water and emulsion added to the tanker. So these are the key elements of information that you will need to calculate the new amount of emulsion being applied to your road. There are a couple ways to calculate the new percent residual asphalt in your material being applied. We'll cover the alternate method. There's another method that's also mathematically correct. So there's a couple ways to do this, but this seems to be the method that most people understand the easiest. So the first thing we want to do is get our information off of our tape and bill of lading. So you're going to have the weight of emulsion that was supplied originally. And then the bill of lading is going to have a percent residue rate. Again, that should be around 60-40, being 60% roughly. So that will give us the residue on the top of our equation. And then below the denominator, we're going to have the total materials, which is the original emulsion, which is the residue plus water of the emulsion, plus the added water. So this is everything together. And then we're going to calculate a new percent of residual material. And then from that, we're going to determine the pounds of residual asphalt applied by taking our truck weights, the gross or initial weight minus the final tare weight. That gives us what's applied. We're going to multiply times that new residual rate of the asphalt, and that will give me the pounds of asphalt applied to the roadway. So here we have a bill of lading for a project that you're working on. And what we need to do is to calculate the new percent residual asphalt that's being supplied to the job. So we have our bill of lading. It's an SS1 material. The residual rate of this material being supplied is 57%. In making the blend at the terminal, started out with 8,300 pounds of this original emulsion and added to it 2,208 pounds of water. This was made up a transport that came to your job. They had a tare weight on it. They added this blend to it. So we got 10,000 pounds, 508 of material that came out to your job. You loaded up your distributor truck from this tanker. So you have some weights on your distributor truck as far as before and after application. So it's loaded up. You got the before weight, 31,200, and then the final truck weight on your distributor, 21,420. So first thing we need to do is calculate this new residual percent asphalt that we have from this blend. So we need our weight of asphalt emulsion from the original weight, which is 8,300 pounds, times the residual residue rate, which is 57% or 0.57. And then the denominator of this equation is going to have all the material that's supplied, which is the emulsion plus the water. And that comes out to be 0.4502, or just a little over 45% residual residue in this new emulsion. So that's the value we need for our next calculation. So now we have our truck information from what's been applied to the project. Again, this was offloaded onto a distributor. It weighed 31,200 to start with. We applied the prime to the road. We finished with 21,420 pounds. So this difference is what's been applied to the road. and what we need to pay for in our calculations. So we got initial weight minus our final. So there's our truck application times this new residual asphalt percentage. We crank that through and we should get 4403.2, and that would be our residual asphalt for pay. Let's take a look at what we would do for cutbacks. Cutbacks such as a Rapid Cure 70, it's an asphalt that's been cut back or dissolved, if you will, with a petroleum distillate such as kerosene or naphtha. You do not add water to cutbacks. You get curds and whey if you do. Water and cutbacks do not blend. So it comes out to the job. Your bill of lading will, in this case, say it's 60% asphalt. So your calculation is pretty straightforward. Here's our bill of lading for this cutback asphalt. We got RC70, so that's the material. It has a residue rate of 60%, and our transport had a gross weight and tare weight taken, so we know we have a net of 51,880 pounds. The specific gravity in this case, because these lighter petroleum distillates weigh less than water, is usually below 1, so 0.95 in this case. Here we're doing calculations on a tape for, could be an emulsion that has not been diluted or a cutback. So our truck came out, we had an initial weight, we applied the prime and got a weight after the application. Take the difference. So this is the amount that is on the roadway. And then we need to take our factor for the percent of residual asphalt from the bill of lading. In this case, it was 0.638. So it's just a simple multiplication. And then that's how many pounds of residual asphalt that was applied to the roadway. And that's what our pay is. Again, we're going to put our stamp on here. So who it's measured, calculated, and checked by, our contract information, and we're all good to go. So let's go to Workbook page 19. Here we have a prime tack coat example problem. We'll go through this. We have a bill of lading. Again, the important information on the bill of lading is the residue, the weight of emulsion that we started out with at that residue rate, and then the water added. There is some additional information, but we will not need that for any of our calculations. Then we go to our job site. We offloaded some of this material onto a distributor truck, got a weight of that, applied it to the roadway, which had a length of 12,713 feet and a width of 12 feet. And then after that application, we weighed it again, so we know how many pounds of this combined material was applied, which is supposed to be at 0.05 of a pound per square foot per the specification. So the question that we're given is, from this data, we want to know the residual asphalt applied, the actual residual asphalt application rate, the theoretical, so this is kind of a yield check, and the maximum pay of the residual asphalt. And then our pay quantity. So there's a number of things to do here. Let's go ahead and get started. So that you can follow along a little bit, let's highlight some of the areas that we're dealing with. The residue rate of 60% is needed. We need to know how much emulsion we started out with and then how much water was added. That, along with the information of what was applied to the roadway, which is the initial distributor weight and the final weight. From that, we can calculate the residual asphalt applied to the roadway. So let's do that calculations first. Just so we can follow along here, here is how we're going to calculate this new percent residual asphalt. We're going to take the weight of the asphalt emulsion times the residue rate, which is 0.6 or 60%. So that gives us the amount of residue in our blend. And then we have all the materials involved. We have the emulsion and the added water, and we divide that through, we get 0.42 or 42% is our new residual residue rate. So we have our information from application. We have our initial weight minus our final weight times our 0.42, which is the new percent residual asphalt, gives us 7750 pounds. So that's how much material has been applied to the roadway. So we take the value we calculated, which is the actual asphalt applied, the residual applied, 7750, that goes here. Next, we need to take the length and width of our paving job and the rate of application to determine the theoretical rate that should have been applied. And we will also take this area and determine what the actual rate of application was. And then we'll calculate what the maximum pay could have been off of the theoretical. If you look at page A15 in the dot guide, or you can look up the actual specification for the material, you'll notice that there is a maximum pay percentage, which in the case of asphalt prime and tack is 105%. So once we figure the theoretical residue asphalt that should have been applied, we'll take 105% and that will be the max pay. Then the question is, what can we pay? Is the rate applied? Can we pay for all of it, or are we limited by the max pay? So on Workbook page 38, we have the summary of these calculations. You can follow along there. So again, our application area, we got our length and width. So we calculate the square feet, and then multiply that by the rate for our theoretical. So in theory, we should have applied 7628. We also take that area and divide the number of pounds actually applied by the area to come up with the rate that was actually applied, 0.0508. So the application rate is just a little bit heavier than the theoretical. So that's why our theoretical is a little bit lower than what was actually applied in our calculation. Now, for our maximum pay, we need to take our theoretical and multiply it times the 105%, which is found on A15. So we can pay up to 80,009 pounds for this pay item. They applied 7750. It's very close and a little bit over the theoretical, which is good. And we can pay for all that. So that's our answer. So here's our table completed, our residual applied, our actual application rate, theoretical residue, our maximum pay residue amount, and then we can pay for what they actually applied to 7750. Okay, let's move on to documentation page F63, where we're going to cover another pound item, which is fabricated steel. So in this case, we have some angle irons being provided to a job. The resident drew out what it was. There's an angle that may be eventually welded onto the bridge or as a stiffener or whatever. There's a hole cut out. The bill of lading indicated that the weight of steel should have been 3,200 pounds. However, the load of steel was taken to an improved scale at Effingham. Got their scale information, got the weight tickets on file, and they determined the actual weight was 3,140. And there could be a number of reasons that there's a difference. Some of it could be that in the fabrication process, the bill of lading represented the entire piece, and then when the hole was cut out, that's removed. And that's material is lost, it's not being installed on the job, so we don't pay for it. So that could be one possible reason there's a difference. Could be just the weight of the material before and after fabrication based upon the bill of lading. Could be a number of reasons, so it's a good thing to check. Steel is usually a high value item, so a few pounds can make quite a bit of difference on your pay. Let's talk about another pound item, and that's nutrients, fertilizer. Here we have an IDR, which is found on page F64 of the doc guide. Header information, as usual, job stamp, those sorts of things. And then we have our pay codes. And we pay for nutrients by each nutrient. It does not come out that way necessarily in the bags. If you have bags being supplied, you have to do a little calculation to determine the actual nutrient, because we pay for the nutrient actually being applied to the job. So we may have bags come out, the contractor perhaps got a good deal on 10, 10, 10, and that's not quite what we asked for the project. So there's some material we would not be paying for if they exceed those values. So we want to make sure we calculate the individual values. So the plans require so much nitrogen, phosphorus, and potash per acre. Now the contractor did find a 10, 6, 4 and 50-pound bags. So that does match up with the rate of additives on the fertilizer. So it's just a matter of confirming the guaranteed analysis from the bag. You may want to cut off that part of the bag and put it in your file. So they use 140 bags, and we got to do a little calculation. 10 means 10% of that bag is nitrogen. 6 is the second number, which is the phosphorus. So that calculation, and then 4 is the potash, which is the last item. So they're always in this order of nitrogen, phosphorus, potash, alphabetical, if you will. So we need to do the calculation. So 10%, 6%, 4% of 50-pound bags, there's 140 of them. Gives us our 700, 420, and 280. That's what we have here. And a little yield check. 7 acres. How many pounds per acre were being applied? Confirm that the yield is good. In the case of fertilizer, quite often you have subcontractors in an area that would be doing the landscaping work on projects. And it's just too much of a temptation to show the resident a bunch of bags and claim that nutrients have been applied to the job, whereas maybe only half of it had been. So just as a measure to prevent the temptation, collect the bags, count them, and then destroy them. either pack them off to a different dumpster or burn them or whatever the case may be, but you're going to destroy those bags in some fashion, so they cannot be gathered up and presented on a different job as being applied